All right, again, this is Mr. Hayden. This is Earth Science Week 5. What we're going to be doing is talking about the oceans. Some of the slides I was telling we're going to click back fast, and we're going to stay a little bit longer on. If you have any questions, make sure you put them in the Dropbox. If you have any questions after the session is over, make sure you email me. And ask me very specific questions, not questions like I don't get science. That's typically a little too broad, which has been asked. Kids are like, can you do me a favor? Can you teach me science? And I'm like, and no. I didn't know how to answer that. I was like, and no. I'm just not really going to go with that, actually. I'd say pick up a book. Let's start with any book, and then just start reading from the first page, and then when we have a question, ask. So we'll go ahead and get going. Again, the essential question, I'll put on the next two slides, or one of these slides. I realized that I put it on there, but then I didn't hit save when I close it out, and then it needs to go on there. So what we'll do is I'll just put it actually right down here. So let me do this. File, edit, where am I at? Insert, tools. Oh, I'm just kidding. I don't know what I just did. So hopefully I didn't mess anything up. Okay, so let's put it right here. So the essential question, and I'll change all the fonts and everything, is describe the salinity differences at the mouth of a river and explain how they how they are the same in the Arctic. There you go. Question / not question. All right, let's go ahead and make this so you can actually see it. Okay, let's make this white. Bam. And let's change the font to large. Let's do it right now. And again, this is something I already did, but I'm glad it didn't save. So I apologize for that, but here it is. Make it bigger. There you go. You can do this. Drop the essential question right there. Okay, so again, and we're going to be looking at this a little bit in class. We're going to answer some of this stuff in class, and some of the stuff you'll have to do by some of the readings you'll actually need to find. So I'll turn it this way because the echoing of the thing.
Okay, do you need me to click through it?
Yeah, if you can.
Yeah.
Okay, so the people in class are now on the same page in what we're seeing here. So again, a couple things we need to talk about. The ocean. Been there before, right? Cool. Some people haven't been there before. Really weird. Think about people who are born in the middle of this country. They've never seen an ocean. Some of them have never seen an ocean. That's actually kind of crazy to think about. You guys used to. You guys are California people. The ocean, right there. Other people are like, I want to get on a plane so I can fly and look at the big blue thing. Really quite interesting. So what we're going to do is we're going to talk about specifically about the chemical and physical properties of salt water, or seawater, because it's different than regular water. Okay, there's different salt content, there's different temperature things, and all the stuff that we're going to be learning today. Next, topic right hand corner. Oh, what's the slide for? You have to put it over here. Sorry, what it is. Because they won't hear me at this point. Okay, so again, we're going to talk about properties of water. We're going to talk about a little bit of ocean circulation to an extent. We're talking a little bit about waves, not so much tides, okay? We're really not going to be talking about tides because we're going to get into tides when we start talking about space. Because that's where we start talking about the moon and how the moon kind of messes with things and all that stuff, why everyone's rigging the moons out, that type of stuff. Next.
So the arrows won't?
Yeah, you should click on it. Over here. Okay, one thing that I found is unique against water. Water is a polarized molecule. You guys know what that is, polarized? And one side is negative, and one side is positive. And so this occurs because there's positive hydrogen molecules down at the bottom, and there's a negative one at the top. If you didn't have that, we wouldn't be alive. This little thing. Right here. We wouldn't be alive. Because of this, water floats when it freezes, and it floats on top of the surface. If it didn't, it would sink. It would be heavier, just like anything else that's more dense, it's heavier. So it would sink to the bottom of the ocean. It will never, ever, 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 ever it would just get frozen, then be more frozen, and it would just kind of make its way to the surface. You have a little bit of water on the top, but all the oceans would be probably frozen then. We wouldn't be alive. We need the oceans to kind of jumpstart humanity. Next. Jacob has a question. Let's see if we can answer. Can you click on the bottom? Jake, what do you got to say? Yeah, you can use that. Wait, what? Okay, I professionally borrowed it. All right, professionally borrowed. All right. A couple things about water in general. There's 3 different states of water. Okay, Montana, Nebraska, and not that type of state. It's actual states. Okay, like it's ice. Ice kind of makes its way in this beautiful little kind of like circular thing in the bottom of the left-hand corner. And, you know, that's why I make, snow flakes and stuff all beautifully and melty and all that. And that's the way it sets up. That's what makes it less dense. They don't compact. They kind of make more space in the middle and kind of hang out with each other. Once you add some heat, okay, so you add some temperature either from the sun, fire, whatever. We talked about this last week. It changes from ice to water. Then you add more heat. 220 degrees Fahrenheit. It finally becomes a gas. These changes in states, the Earth does all the time. It's part of what we call the water cycle, which we'll see in a little bit next. Okay, next, we'll need to know that. It's really, like, do I need to explain how ice melts? I mean, if I have to, I'll sit there and go through it, but that's what it just says. Ice melts when it gets warm. We're good, right? Okay, so making sure. Heat capacity, we talked about this last week, that it takes a lot of energy to change water into something else. Like to boil water, it takes forever. Like last night, again, I made pasta. I didn't last night, I think the same thing last night. I made pasta again last night. Okay. By the way, there's a difference between tortellini and what is the other one? Which one starts with R?
Rotelli.
Yeah, there's differences apparently. My wife pointed out last night, and that is recorded. Okay, some of you do know. But in general, like you boil it, you put it on there, and you put the fire in it, and it takes 20 minutes, and finally it boils because of the energy, the heat capacity, the specific heat it takes that to actually move. It takes a lot of energy. But when it moves fast. Okay. Okay. Now you're gonna go over how evaporation works. Okay, you went good? You good? Okay, evaporation is when heat basically like you leave water there and it heats up to the point where water at the top jumps off into the air and it just does that continuously until there's no more water. Okay. Okay. Oh no, water cycle. So this is the water cycle. The same thing I told people. Who here drinks water? Okay, do people online drink water too? Give me a smiley face if you drink water. All right, you have water there. Now, a question for you. There's 2 rules about anything about science that you should know. One is, nothing on this planet can either be made or destroyed. Got it? Everything here is here. Okay? Example, you were here. You didn't just show up. You were a combination of other molecules that were already on this planet put together to create you right now. When you go away, your chemical will be relevant. That's just the way it works inside organisms. But your water follows the same concept, which means that water you're drinking there has been around for 4 billion years. There's a good chance the dinosaur drank that too. Which means there's a good chance that they made it dirty. Let's say that. There's a good chance the whole ocean does it all the time, because you drink the water. Because water itself is just H2O. 2 hydrogens and an oxygen, not all the other stuff. This water cycle you see behind me and people on the internet, someone's asking a question. Let me just quickly see what they have to say. The essential question I already went over. It's at the beginning. You can watch it if you want to see it. Okay, so here's the water cycle. So this ocean is just a big reservoir of water. Okay, there's a bunch of salt in it. We'll get to that in a second. But basically, it needs to leave. What kind of process does it take for water to go into the air?
Evaporation.
What was it? Evaporation. What was it? What was it? I can't hear you.
Evaporation.
There it is. Got to make sure they hear you on the internet. All right.
Evaporation.
Not just one internet. internets. There's multiple ones apparently. That's what we heard. Yeah, that's what we heard. So it goes up in the air. Same thing you guys learned last week. It will go over land. It will condense. It will go towards mountains. What happens when it condenses? What happens to water when it gets condensed? What they I don't know. You should. I don't know. Over here, Mr. Hayden, don't make eye contact with me. What happens when water condenses in clouds? Louder.
Rain.
What was it?
Rain.
Rain. It rains. So this water that was all salt and other stuff in there that you probably don't want to drink, especially in California where there's just a big tube that goes off the coast and drops whatever it needs to the ocean. Yeah. That goes up into the air, comes over here and drops. It's fresh, beautiful H2O. Two things happen, or a couple things. One is either it comes down in a river, and we drink it from the river and makes its way back to the ocean. It goes underground, which actually most of the water does. People don't realize that, but actually most of the water goes in the ground. And then the other one stays at the top of the snow. And the snow melts in the spring, comes down, and we get to drink that water. Or it goes down to the ocean too. Okay, this is the water cycle. This is what cleans the water and puts water back into the oceans. Yes, sir.
So then the clouds take out all like the salt and all the different particles in the ocean then?
Right, this process, by the way, I'm pointing at the evaporation thing on the internet. If you guys look at the evaporation right here leaves it behind. So example, if you took water, just if you want to go home and do this, if you're super bored, it's fine. Take like a can of whatever, like a can or a cup or anything like that, pour a bunch of water in it, then pour a ton of salt. Like a lot of salt to the point where it doesn't dissolve anymore. It's called super saturation, where it just can't dissolve anymore. And then just leave it outside for days. At the end of that whole thing, what is going to be left?
Probably just like salt.
That's it. That's all will be left. That's the exact same process in the ocean. All this water just leaves. There's no cleaning in the clouds. The clouds are just formation of water and other condensation nuclei. Remember? That's what we learned. But right here, it basically just leaves it behind. It's like, salt isn't too good for you. I'm going to be leaving. And it just leaves it. It leaves the salt behind, which changes salinity, and that's what we're going to get to next. Okay, now next. Okay, real quick. Now, how does the salt get there? How do you think the salt got inside the ocean? Okay, we're going to go a volcano. Okay, that's an idea. What's it?
Aliens.
Aliens. It is so far leading in the clubhouse. Let's see it again. Okay, let's go with the idea. Now, oceans at one time weren't here. That ocean was not here. It was gone. Volcanoes. Earth was just big molten rock. But the water, remember I told you, it didn't just come here. It was here. It was locked inside the earth. So when you said volcanoes erupt, let all the steam and stuff go into the air. Well, eventually condense and start raining. A million years or so. If you think about it, how much rain would it take to fill an ocean? Or a lot. It hits the earth, it's salt deposits, grabs the salt, pulls it down with it, out into the ocean, salt in the ocean. Oceans are the lowest point on the planet Earth. Some of them. I shouldn't say all, but they're like the deepest parts here. That's why the water funnels down to that area. It goes deeper than where we're at now. It actually goes downhill at this point. That's why the water settles there. So all the salt got there to do the runoff that you see on the slide here, sodium chloride. Now, what I always found is sodium chloride is weird. And if you look, there's sulfide and chloride, right? They go together. If you eat sodium by itself, you're done. Sodium actually usually, like you can't keep it like a regular state. You're supposed to keep it in like oil. And chlorine, you eat that, not having a good day. Okay, if you put them together, you put that on your food. Salt. It's kind of weird to me. I always found that interesting. You take them apart and you put it. But it's the same when you got to change the food. Next. There's some questions here. The essential question has to do with the oceans, very specifically in salinity. You can see that on like the first or second slide if you go back and rewatch it. We see some other questions here. Let's see what they are. I'm glad that you just put volcano. Good. Because you knew the answer. I like it. All right, just so you know, there's other things in the ocean other than sodium chloride. There's these other things. The reason why we talk about salt so much is because look how much concentration there is. Like 85% of the ocean is of these chemicals is salt. But then there's all these other ones like magnesium, calcium, potassium, borate, bromine, all these other ones, right? The fluoride is one that's not very much of it, but that helps keep your teeth nice and strong. Fluoride helps your teeth. Areas that have high fluoride content in their water supply, people have a tendency to get higher, like more healthy teeth. People who don't, not so much. Teeth fall out. So. Okay, so here's the question. I just kind of have to go through such a question to an extent. I'm going to pick out a couple situations and we're going to see, do we think that the saltwater salinity is higher or lower? Just so you know, all over the earth, all over the oceans, there's different salt levels. Some are higher salt salinity, some are lower salinity. What we need to know is what would affect us. So I'm going to give you a couple situations. I want you to think about it in your brain. Don't use anyone else's brain. Okay? I want you to just kind of think, what is that? For example, ocean, right in front of you. There's a river pouring water into the ocean. What do you think the salt level is going to be around the area where those two are mixing? Do you think the salt level will be higher, or do you think the salt level will be lower? What do you think? Lower. Okay, we hear lower. I hear lower. Online, give me a downward with a thumb down if you think lower, and a thumb up if you think higher. Not a hand, Jacob. Thumb up or thumb down. All right, so, okay, you think it's going to go down, right? Good, all right. Guess what? You're right. But do you know why you're right? Now, you can get an answer right. It's like 50-50, right? It's up, down, like a gladiator. I'm just like, deciding if the guy's going to, like, be around.
Because of the fresh water going in, and it could be more water in this salt.
Exactly the right answer. Because the river is fresh water. It's pouring into an area of salt. So what happens, like, if you have a cup of salt water and it's in there, right? You can't drink it, right? I mean, big cup of salt water, you're not going to drink it. We agree we're not going to drink a big cup of salt water. So I guess you're getting there again. But if I was to take that and pour it into a freshwater pool of fresh water, pour it right in the middle, mix it up, would you drink that water? Perfectly fresh. No one's been in it. No one's been in it. Yeah. It wouldn't affect you. Because you just added a whole bunch of fresh water to just a little bit of salt. Yeah.
That's another good idea. So, like, say I had a bucket of salt water.
Bucket of salt water.
From the ocean.
From the ocean. Clean salt water from the ocean, or are you going to have all the stuff that you need?
All the stuff inside it. All the salt, all the particles, everything.
Okay, good.
And I leave it in the sun. And I let it evaporate for like 3 weeks. Then would the bucket have salt?
Yes. That's actually how some people get the sea salt that they put on there.
So like it's edible too?
This is what I was saying. I would say that the particles left behind you probably don't want to have in your mouth.
Probably not.
Here's a hint. You guys ever been to the ocean when there's like after a storm,
Like
they put those signs up that say high bacteria levels, right?